Hello everyone, and welcome back now to the third video in this series in our review on inference for means. This video specifically is going to cover the one sample t-test. So the previous videos we talked about a one sample t interval, a two sample t interval. Now we're going to go ahead and talk about the hypothesis testing portion of this unit. So let's jump right into it and see what's going to be different here with the hypothesis test versus the confidence interval. So again, similar to a one proportion z-test, I'm not going to go crazy with this. We live on the distribution of the null hypothesis. So we're going to assume that our null hypothesis is true, and we're going to take a sample that is representative, just like it needed to be for confidence intervals, and hope that that sample helps to show that our alternative is true. Right? Hopefully it's far enough away from the middle to say that, well, maybe we have evidence that our distribution really looks something like this. But again, everything is done on the basis of the null hypothesis. And so again, importantly, the whole idea of hypothesis tests is to be able to help us draw conclusions about where a population mean is in relation to one specific number. So a confidence interval would give us a range, but for a hypothesis test, we are testing against one number and one number specifically. And we want to know whether we have evidence that it's less than that number, greater than that number, or just not equal to that number. And so that's your biggest difference between confidence intervals and hypothesis tests. Hypothesis tests, we have a direction. Confidence intervals, we just get a range. And so when we talk about our acronym for hypothesis testing, that is our HAT North Carolina. So for my hypotheses, my null hypothesis is that mu, whatever that is just going to be equal to some number. Whatever that number is comes from the problem. My alternative, I still have the same three options of greater than, well, that's actually less than, greater than, or not equal to. My assumptions are the same as a confidence interval. I need to have two random samples, I need to have one random sample, and I need that sample to be 30 or more people, or I need to have that condition or the sentence that the normality assumption is met, or I need to make a box plot, or I have a stem plot and I'm looking for no skewness and no outliers. My test is a one sample t-test. For my numbers, you're going to get your test statistic, which is your t, the p-value from your calculator. We'll list our significance level, and again, don't forget your degrees of freedom. Degrees of freedom here is still n minus 1. And my conclusion is the same as all of the z-tests that we did. We either reject or we don't reject. Those are my only two options when it comes to a hypothesis test. We're either rejecting the null hypothesis or not rejecting the null hypothesis. So let's take a look at an example here. Right now, this question is very long in and of itself because there were multiple parts to this, but we're just going to take a look at part A. And so we have a bottle filling machine that's set to dispense 12.1 fluid ounces. And to make sure it's working accurately, we randomly select 4 bottles during the past hour and measure it. If we get evidence that that mean amount is different, that's the key. Different tells me my alternative hypothesis is going to be a not equal to. And then, the second part here is about the standard deviation. We're not going to worry about that right now. Then the machine is shut down for recalibration, and then blah, 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 normal distributed. Here's the important thing. We get that sentence about the normal distribution. That is really important because my sample size was only 4. But the other thing in this question that gave away that I needed that was I wasn't given data points. 1, with 4 data points, it would be impossible really to see shape at all. Your box plot would be non-existent in reality, your median in your first quartile or your median in your third quartile would be the same. It would be a giant mess. It would be impossible to make. The other sentence that's incredibly helpful here is this one right here. Assume that the conditions for inference are met. So that means for our assumption part of our hat North Carolina, we can just quote this part of the problem and move on. It is my favorite sentence in all of hypothesis testing. And so let's go ahead and run this hypothesis test. So for my null hypothesis, I'm going to say that mu equals 12.1. And for my alternative, it's that mu does not equal 12.1. And I'm still going to define my parameter here as the true mean amount of juice that's being dispensed. For my assumptions, assume all conditions have been met. Love that. My favorite thing. Now the test is a one sample t-test. And so now for my numbers, I'm going to plug this into my calculator. We were not given a significance level here, which usually means that it doesn't matter what your significance level is. Your p-value is either going to be greater than all of them or less than all of them. I'm going to be either a really big p-value or a really small one. But I do know that I have 3 degrees of freedom because I had a sample size of 4. And so when I plug this stuff in here to my calculator, the mean was 12.05, the standard deviation was 0.085, and the sample size was 4. Let me find a different calculator because this one is not working. Let's see here. Okay. Hopefully this one works. Oh, this will. My sample average, my sample size, and my sample standard deviation, and then I calculate it. There we go. So what happens here, I get, not so surprisingly, a t-value of negative 1.17, a p-value of 0.324, and let's just pick a significance level here of 0.05. But for my conclusion, since my p-value is greater than my significance level, I do not reject my null hypothesis. I don't have evidence here that the true mean is different from 12.1, and that probably wasn't surprising given that the sample mean was 12.05 and the hypothesized one from our null hypothesis was very close to that at 12.1, which was less than 1 standard deviation above the mean. So I hope that was helpful for one sample t-test, and I'll see you guys in the next one.